Okay, so the triangular prism is a transparent medium bounded by three rectangular surfaces whose upper and lower surfaces are triangular. Let me quickly send this shot on the page. At least it will give you a picture of the triangular prism. A picture of what the triangular prism is. Anita.
Sir, please, did you say it's bounded by three triangular or rectangular surfaces?
Rectangular. Yes, I know that part. That part is a bit confusing. We are talking about triangular prism, but we are told that it is bounded by three rectangular surfaces whose upper and lower surfaces are triangular. Please open to the picture I just sent on the page. Just open to the picture, which is just forwarded to the page. Have you done that?
Yes, please.
Good.
Yes, sir.
You see the part which is colored in blue. These are two rectangular surfaces, and the base is also rectangular. Anita, have you seen that?
Yes, please.
So the two are inclined plane, AB, and then what looks like AB and then AC are rectangular, as well as the base. And these three rectangular surfaces, which are bounded, forms a triangular prism. So that is basically what we mean by the triangular prism. Now, these prisms have a lot of uses. Last time we looked at the application or the use of the rectangular prism, and we saw that they are used in optical instruments for refracting light. So the triangular prism is used as such. And Morris, please mute yourself. Morris, quickly do that for us. I have this binoculars. You know, this usually when I see these instruments that are totally embodiment of physics, I try to buy it. I mean, look at it into details. Okay, so the binoculars we use are actually embodiments of lenses and prisms. When I opened it, I saw triangular prisms within, and these are what instruments use in giving you a larger magnification of distance objects. So we use these lenses for refraction of light. We also use them for dispersion of light. Now, when you incident visible light or white light through a triangular prism, through a principle known as photometry, the white light can be dispersed into each various component, and that is dispersion of light. And we use this to do that, the triangular prism as well as the rectangular prisms as well. So prisms have actually a wider applications, okay? And I gave you applications of prisms when we're looking at rectangular. So I'll repost it again for the benefit of those who did not start with that. So refraction of light refraction of light in triangular prism. That's our next substrand. Okay, so let me quickly take attendance and then post it on the page, as it's also a very important aspect of engagement. So give me a minute or two to quickly do that and get back to you, okay? Okay, so back to you. So refraction of light in triangular prism. Let me give a quick sketch of the triangle, or one of the principal faces of the triangular prism. So this is one of the faces of the triangular prism. The triangular prisms have that uniqueness in their refracting angle. Different triangular prisms have this unique angle. So let's assume that the angle to this particular one is A, meaning when you are going to buy triangular prisms, you go with specifications. Maybe I want a triangular prism whose refracting planes, inclined refracting plane makes an angle of 45, 30, 60. So these are details in buying triangular prism. They come with different refracting angles. I'll talk about this. So we are only assuming that let the refracting angle of this be A. So let's name the vertices. We have the point A, B, C. Okay. So the details are: one, the refracting angles; two, the nature of the material. Triangular prisms can be made of glass or plastics. So if you want to buy triangular prism, you must go with the nature of the material used as a prism. Maybe I want plastic one or glass one. And then being it plastic or glass also has its refractive index. So you must go with the refracting angle, maybe the kind of material used in doing it, and then perhaps you can also talk about refractive index. Now, unlike rectangular prisms, if you recall, refraction of light in rectangular prisms, we saw that if light incident at one plane of a rectangular prism A, B, C, D, when you incident light at one side, so this is a normal, because the light is from air to glass, it will bend towards the normal. This becomes the refracted ray. And when it is coming out of the prism, it will refract away from the normal. This angle becomes the angle of emergence. This is the angle of incidence. And when the light is from air entering into the prism, and it is also coming from prism to air, then we expect the angle of incidence to be equal to the angle of emergence. This ray is known as the emergent. Are you there? Class, are you there?
Yes, please.
And no one is even coughing. That's why I asked. So the emergent ray, this is the incident ray. So I is equal to E because one, the light enters through the prism, okay, through air, and then it is coming out also through air. And two, I is equal to E because AB is parallel to DC. And so when you have these conditions, okay, in place, you have the angle of incidence being equal to the angle of emergence. So if this is 30, this must also be approximately 30. And the incident ray, when it is extended or extrapolated, must be parallel to the emergent ray. That is how come we could measure the dispersion D. Okay, so with rectangular prism, whatever happens here at AB, the same thing also happens to the side DC. Now, under refraction of light in triangular prism, it's different. Let's draw a normal to this side. So A is the refracting angle of the prism. Refracting angle of the prism. Or other books describe that as angle of prism. Okay, and then triangular prism has two refracting planes. There are two refracting planes, AC, so AC and AB, are two refracting planes. And BC is the base of the prism. BC, base of prism. Okay, let me check on. Yes, I'm recording. All right. So these are the parts of the. Now, I've explained to you what A is. AC and AB. AC and AB are two refracting planes. So what it means is that if light incident at this side, this is one normal. So this is N1. Normal is always, this normal is perpendicular to AC. When you incident light at the side AC, it will be deviated. the path of the light will be deviated. So this is the incident ray, meaning this angle is the angle of incident. So when light hits AC, it will bend. Now, at the boundary, at this boundary O, or this interface O, because the light is from air entering into glass, it will bend. Class, how will it bend? Will it bend towards the normal or away from the normal?
Towards the normal.
So it will bend towards the normal. Then, when the refracted ray hits the other refracting plane AB, this is a refracted ray. Once it is incidenting at AB, it means we have to draw another normal. So there is a second normal, which is perpendicular to AB. So N2, the second normal N2. When the ray is coming out of the prism, the triangular prism, this time it will bend away from the normal. And for the prism, this becomes the emergent ray. This angle also becomes the angle of emergence E. Okay, so when you incident light in a triangular prism, the light goes through double deviation or refraction within the prism. Unlike rectangular prism, where the light is deviated once, of course, AB and AC will be, but whatever happens here, the same thing also happens here. Okay, so for triangular prism, when you incident light, it goes through double deviation within. Now, the advantage the triangular prism has over rectangular prism is that this has the ability to combine refractions at the planes AC and AB to form a larger deviation. Please write that. The triangular prism has the ability to combine refractions at the planes AC and AB to form a larger deviation.
So, please, I didn't get it. So, please, can you come again?
What I'm saying is that the advantage triangular prism has over rectangular prism is that triangular prism has the ability to combine the two refractions or deviations occurring at its planes, okay, to form a larger deviation. Kweku, I am for leave my board alone, Kweku. Okay, so it's able to combine deviations at its planes AB and AC to form a bigger or larger deviation. For rectangular prism, the deviation at AB seems to be cancelled by the deviation at DC, all the same. But for triangular prisms, because of its architecture or nature, deviations occur at the refracting plane, inclined plane AC and AB, and the prism is able to combine it to form a larger deviation. And this is very, very important for the dispersion of light. This ability of triangular prisms to combine deviations at its planes is useful for the dispersion of light. And you understand how it will be, how that is done. So if this is the incident ray, when we extend this light, the incident ray to its original path, we have this. I'm just extending it. 2. Binding, please mute yourself for me. When we extend the emergent ray backwards, emergent ray backwards, let's extrapolate this to intersect with the first one. Let me change this color for clarity. Good. So to the first plane AB, AC, its angle of, please, what is this angle? Can somebody tell me what this angle is? What is this angle?
Angle of refraction.
Good. So angle of refraction, don't forget, angle of refraction is the angle from the normal to the refracted ray. So this is the first angle of refraction, R1. Then this is the second angle of refraction with regards to the plane AB. So for plane AC, this R1 is its angle of refraction. For the plane AB, R2, this is R2, the second angle of refraction, R2. Let's combine the two normals to join or to intersect. So when we extend this, and then the second normal, they will all intersect here. We'll use this for for a very important analysis. Okay. What do you think is this angle? The angle between the refracted ray and then the incident ray. What is that angle? Can somebody? Angle of deviation. Thank you. So to the plane AC, this is the first angle of deviation. To the plane AB, this also is the second angle of deviation, D2. Now we see this angle between the incident ray and the emergent ray. This angle, Morris.
Please, I can't really hear you.
Oh.
Like the line is breaking.
Please, is it a general problem to all?
No.
Then, Morris, I think it will be a network problem from your end.
Sir, please also mind. Mine is breaking a little bit.
I think it's a network issue. But is it better? Is it better now?
Yes, please. Yes, sir.
Okay. So this angle between yellow. Okay. This angle between the incident ray and then the emergent ray, this is the total deviation, D capital T. It's a subscript. Total deviation. So where, let me define my variables, where D1 is equal to the first angle of deviation, then D2 is also the second angle of deviation. Can you define R1 and R2? Class, can you define R1 and R2?
Yes, sir.
So
Yes,
do that
please.
quickly. R1 is a first angle of refraction and R2 is the second angle of refraction. Then E is the angle of emergence. E is the angle of emergence. And finally, D total or D subscript T is equal to the total deviation. The total deviation within the prism. dt is the total deviation. I earlier said that triangular prism has the ability to combine deviations at AB and AC to form a larger deviation, and that larger deviation is D total. So D total must actually be equal to deviation 1 plus deviation 2. The value of D total, this angle, must be equal to the angle of deviation here plus the angle of deviation there. Are we okay?
Yes, please.
Can somebody help me determine D1? How do I determine the first angle of deviation, D1? Can somebody help? Anybody?
It is the total deviation minus the second deviation.
Not from here, but from the first refracting plane AC, because of vertically opposite angle reason, you could see that I is equal to R1 plus D1. Therefore, we can say that D1 is I minus R1. Class, are we okay?
Yes, please.
All right. Morris, I hope your line is stable now. The audio.
Yes, please.
Morris, how do we determine D2? We want to
Please,
calculate D2 for D2.
so please, it will be the emergent ray minus the second refracted ray.
The second angle of refraction, R2 rather. Well, so E minus R2. Frank.
Please, I have a question. How was the emergent ray formed? I don't understand.
The emergent ray.
Yes, please.
So when the ray enters the prism, okay, it would come out from the prism, okay, through this other plane AB. Okay, so this is the for the plane AB, the angle, the refracted ray becomes the incident ray, and because it is coming from glass to air, it will bend away from the normal. So this is the second normal to the plane AB. Frank, are you following?
Yes, sir.
So the emergent ray, which is the ray coming out of the prism, the angle from the second normal N2 to the emergent ray becomes the angle of emergence. And for refraction of light in triangular prism, I is not always equal to E, even though the ray is emerging from the into air, okay, enters the prism from air, emerges out of the prism into air, but it is not all the time that the angle of incidence is equal to the angle of emergence. But for rectangular prism, it is like that all the time. Class, I hope you are following.
Yes, please.
All right. So here, note that it is not all the time. It only occurs on some condition, which we'll talk about later. But for rectangular prism, it is always. So we have expression for D1, we have expression for D2. Let's substitute them into the total deviation formula we had. We earlier said that D total is equal to D1 plus D2. So if we have expression for D1, which is I minus R1 plus expression for D2, which is also E minus R2. Let's group them properly. So we can have I plus E minus R1 plus R2 for the total deviation within the prism. What this means is that the total deviation can be obtained by summing up the angle of incidence and the angle of emergence, and then subtracting the sum of the first angle of refraction and the second angle of refraction. So this is another important expression which we have obtained for refraction in triangular prism. Okay. Now, let's label, for the sake of our analysis, let's label this point as well. Let this point be capital E, and let this be F, capital F. This is already O. So when you consider the quadrilateral OAEF, so considering the four-sided figure or the quadrilateral OABF, OAEF, OAEF. Class, what is this angle between the first normal and AB? What is this whole angle? Let me change the color to help you see. What is this whole angle? This whole angle. Can somebody help? I mean, what's the value of this whole angle from the normal to the plane ACA or AC? Anybody? Oh, are you people there?
There is 90 degrees.
It's 90 because the normal is always perpendicular to the surface. So the normal is perpendicular to AC. So from the normal to the AC must be 90. What about this angle? What about this angle to AB? What about this one?
Also
90
90.
degrees.
Good. That's also 90. Meaning if we sum this angle 90 and this one, we must get 180. Equally, when we sum this angle and this angle, refraction angle of the prism A, that must also be equal to what? That must also be
180.
equal to what? 180. The reason is that sum of angles in a quadrilateral must be equal to 360. So if this plus this is 180, then this plus this must also be equal to 180. So angle A plus angle OFE, OFE must be equal to 180. Don't forget, the emphasis is on the angle at the middle letter. So if this plus this is 180, then A plus F must also give us 180. Please, is everybody following?
Yes, sir.
Yes,
All
sir.
right. Now, when you consider triangle OFE, considering the triangle OEF or OFE, we can also say that R1 plus R2 plus the angle at F, which is angle OFE, this must also be equal to what? Plus this must also be equal to what? 180. Sum of angles in a triangle. I want you to make angle OFE the subject in equation 1 and substitute this into equation 2 for me. Then give me the final expression. Make angle OFE the subject in equation 1 and then substitute it into equation 2 and then give me the final equation. Abrina, Akosia, Eletia, Nanakumi. I'm waiting for all of you. Angie, Amen, Alvin, yes, Gideon. When you substituted, what's your final answer?
The
Pardon?
final answer is R1. The final answer is R1 plus R2 is equal to A.
Exactly. So when you make, from equation 1, when you make angle OFE the subject, you have this to be equal to 180 minus A. Come and substitute this into equation 2. So if you substitute this into equation 2, let's rewrite equation 2. Equation 2, we have R1 plus R2 equal to that. R1 plus R2 plus angle OFE being equal to 180 degree. So if you substitute what we had for angle OFE, you had 180 degree minus A. So you have R1 plus R2 plus 180 minus A, which is equal to 180 degree. And this will reduce to 0. And you eventually have a very important equation. A is equal to R1 plus R2. This is a very important equation we'll be using. What we are saying is that the refracting angle of the prism A must be, the value of this refraction angle A must be equal to the sum of the first angle of refraction and the second angle of refraction. So this is formula for the angle of refractions and then the refracting plane, very, very, very important. Please, is it okay to you, to every one of you?
No, sir.
Yes, please.
Echo, where lies your issue?
Sir, I got disconnected when you were explaining
Okay, so let's go back. So when we considered the equilateral, the quadrilateral OAEF, we saw that if this plus this is equal to 180, then the angle of the prism A plus F must also sum up to be 180. The reason is that sum of angles in a quadrilateral must be equal to 360. Echo, are you okay? So that is how come we got A plus angle OFE being equal to 180. All right. Then we considered triangle OEF or OFE. So considering triangle OEF, sum of angles in a triangle must be 180. So angle R1 plus R2 plus this angle OFE must also give us 180 degree. Please, I hope you're okay. We're okay here. Echo and Co. Morris, are you there?
Yes, I'm here. I'm okay.
All right. So consider the the quadrilateral, and when you finish, consider the triangle OEF. Sum of angles in a triangle 180. So that's what we have here. This one, equation 1 is for the quadrilateral. Okay. And this is for the triangle. Then I asked that make from equation 1, make angle OFE the subject. You did that, and then we got angle OFE equal to 180 minus A. Then factorize this into equation 2. Okay, factorize this into equation 2, meaning wherever you see angle OFE, substitute 180 minus A. And then we did that and then saw that the whole equation will be equal to A will be equal to R1 plus R2. And this is very, very important. Meaning that the refracting angle of the prism A here, this angle must be the same as the sum of this and this. So sometimes we can decide to give you R1, or you see how it can be applied. But we can decide to give you 1 or calculate for 1, give you the angle of the prism, and then be asked to calculate for R2. And this is what you use to determine that. Okay. Let me quickly read your messages. So you see, this is what we have in the diagram, looks like a parallelogram. And for a parallelogram, don't forget, equal opposite sides are the same. So once the quadrilateral we have identified within the prism looks like a parallelogram, then opposite angles must be the same. That's how come if this is 90 and this 90, then this plus this must also, but you see, it can even apply to all manner of a parallelogram, because the sum of the angles in there must be 360. So if this plus this is equal to 180, then A plus this, when you sum them up, must also be equal to 180. It doesn't necessarily mean that their values must be the same, but when you sum the two remaining angles, it must equally be equal to 180 as well. Okay, so whoever sent the question, I'm sure I've addressed it for you. All right. Then we also earlier saw an expression for the total deviation. We saw that the total deviation dt is equal to I plus E minus into bracket R1 plus R2. So if we have finally realized that R1 plus R2 is equal to A, then we can also say that then the total deviation dt within the prism must be equal to I plus E minus the refracting angle of the prism, which is this one. Class, are we okay?
Yes, please.
Good. So these are very, very important aspects of refraction of light in triangular prisms we are looking at. Saki,
Davis, I'm still finding it difficult to understand.
where?
So
Saki,
please,
where?
from the previous slide, from the part where you said the equation 2 was from the triangle, that part.
Okay, let me redraw it again and then explain something to you. Maybe others are equally in the same soup. So we need to heat it again in order to cook well. Janelle, are you there?
Yes, please.
Anna. Anna is not there. Okay, so this is one principal part of the prism. We have that peculiar angle E, which is unique for different angles. Angle of the prism or the refraction angle. So the refracting planes A, B, C. Meaning when you incident light at AB, it will bend and enter into the prism. And when the light is coming out of the prism into air, it would also bend at AC. So a triangular prism has two bending or refracting planes. Since will be incidenting light, let's draw a normal to both sides. So this is the first normal. N1. Let's incident light at the first plane AB. So this is the incident ray. And so this angle between N1 and the incident ray is the angle of incidence. Of course, we all know that the refracted ray would bend towards the normal. So this is the refracted ray within the prism. When the ray is coming out of the prism, it will go through another bending. And this time, hello. And this, Martin.
Sir.
Martin, mute yourself. Mute yourself for me. I'm getting the feedback here. So when the ray is coming out of the prism, it will bend away from the normal. This is the emergent. This is the refracted. This is the second normal. The two normals intersect to form this triangle within the prism. Within the prism. We want to determine the angle of deviation with regards to AB, the first plane. So when we extend the incident ray, we equally want to get the angle of deviation with regards to the second plane. So we extend the emergent ray where the two intersect. The angle there is the angle of the total deviation. Angie.
So please, I wanted to know if it is possible that, like, the angle of refraction, woman can hit the other side of the triangular prism at the critical angle, hence, like, total internal reflection will happen.
Yes, we will look at all that. Yes, that is also possible, so that the ray will not come out of the prism. We'll discuss that too. So this is R1 and R2. This angle is D1. This angle is D2. This angle between the incident and the emergent is the total deviation. And you'll be in school, you'll be given practicals to show that, do the experiment to show that D1 plus D2 is actually equal to this angle. Okay. So we came to this realization that the total deviation will be, within the prism, will be the first deviation plus the second deviation. We then obtain D1 to be I minus R1. We determine D2 to also be E minus R2. Then we substituted them. D total is therefore I plus E minus into bracket R1 plus R2. So let's pick our equation this way. Then I said, considering the quadrilateral point O, let's call this point as, there's the angle of emergence E. So the point is E, and this is a point F. Taki, are you there?
Yes, sir.
The angle from the normal to the plane AB. The normal is always perpendicular to the plane. So this angle from the normal to AB is 90. This angle from the second normal to plane AC is also 90. So if this plus this is giving us 180, 90, 90, Then this angle plus A must also sum up to be 180, so that the total angles in the quadrilateral will be 360. It is by coincidence that this is 90 and this is also 90, but this one we cannot say that they are equal. All that we can say is that when we sum the two angles, it must also be equal to 180, so that it will add to this to give us 360. Class, are we okay? Are we okay?
Yeah.
Yes,
Yes,
So,
sir.
considering, yes, Gideon.
So please, can you come again on why the angle formed at O will be 90?
Oh, this is a normal. The normal is perpendicular to the plane AB. So if I pick this is 90. This is also 90. This is 90. This must also be 90. Once the normal is perpendicular to AB, the angle must be 90, 90. Gideon, are you okay?
Okay, yes, sir. Thank
Okay. So considering the quadrilateral, A, E, F, O. Since these two angles, the two angles sum up to 180 degree. It means that the angle A plus the angle at F, angle OFE, must also be equal to 180 degree. Okay, and let's pick this to be equation 2. When we considering triangle OEF, because sum of angles in a triangle is equal to 180, it means R1 plus R2 plus the angle OFE. This must also give us 180 degree. Equation 3. Make equation 2. Make angle OFE the subject and come and substitute it into equation 3. When you do that, you realize that the refraction angle of the prism A is equal to R1 plus R2. That is when you substitute equation 2 into equation 3. Please, Saki and the rest of you, are you okay?
So you are
Just,
saying the angle A plus OF is equal to 180 degrees.
yes,
Say,
yes.
meaning individually one is 90.
No, I'm not saying they are precisely 94. For angle, for these angles, they are 90. This one is also 90. But these ones, we cannot say that they are exactly 90, 90, 90. All that we can say is that when you sum them up, they should give you 180. Joshua, are you okay?
Sir, please, I want to see the word since the two angles of. I can't see the word that is different.
No, this is from the normal N1 to the plane AB, okay, giving us 90. And then from the second normal to the plane AC, this plus this should be 180. These ones, they are equally 90, 90. But these ones, we cannot say that they are equal. But all that we can say is that when we add them, they should also be 180, so that it will add up to this to give us 360. That's what I'm saying.
Yeah, I get that point, but I mean, like, since the two angles sum of, like I can't see the
Since
word.
the two angles sum up to 180.
Okay, so it is negative or positive 180.
No, it's positive.
Okay, sir.
Sum up to 180. Please, if you have any question, ask, okay? Sum up to 180 degree. Anita and Co, are you okay, Frank?
Sir, please, what's the relationship between R1 and R2 and A?
A is equal to the sum of R1 and R2. And that's what I've written here. Okay. Therefore, we can say that the total deviation within the prism would be equal to I plus E minus A. This is equation 4. We want to determine the refractive index. Of course, from Snell's law, absolute refractive index is sine of the angle of incidence to the sine of the angle of refraction. So by this, we can determine the refractive index by taking the ratio of the sine of the angle of incidence I to the sine of the angle of incidence refraction R1. That is, if we are moving in this direction. We can also move in this direction. From the light can also be incident at AC. Here we are clearly incidenting the light at AB. We can also decide to incident the light at AC and use that to find the refractive index. From AC, the refractive index would be sine of the angle of emergence divided by the sine of the angle of refraction R2. Whether from left to right or from right to left, the value must be the same. Please, is there any question? Is there any question? Saki?
Sir, please, can you say D2 plus R2 is equal to 90 degrees?
D, come again. Can you say D?
2 plus R2.
D2 plus R2. No,
Is
you
equal
can't say that. That is not correct. Because that 90 is from the second normal to the plane AC. So meaning there is this angle here, which must add up to give you 90. Saki, are you okay?
Yes, sir.
So you can't say that. Okay. Then let's look at, we want to treat everything, and then please, we can also determine the, Anita.
Sir, please, from the side AC, is the incident ray coming from the left side or the right side?
You
I
see,
don't know if you understand.
from what I have drawn on the board, on the whiteboard, the incident ray is coming from the prism and coming out of air. Okay, but the point is that whether you incident the light from left to right or from right to left, the value will be the same. Are you okay? That is why I'm also determining the refractive index using the ratio of the sine of the angle of emergence to the sine of the angle of refraction. So by this, my movement of light is from right to left. Anita, are you okay?
Yes, please.
Okay.
Initially, I thought it would be like the reciprocal, so it would be rather sine R2 divided by sine A.
You see, when you can, if you are moving from left to right, if you want to use that to determine the refractive index, then it shouldn't be absolute. It should be 1 over n is equal to sine of R2 over sine of E. And when you make n the subject, you still have sine E over sine R2. So you can also look at it from glass to air, but it will be the inverse. Anita, are you fine?
Yes, please.
Okay, Joshua. Joshua.
Please, the Snell's law. Then when you're using the formula, are they the same? The sign.
Yeah, it should have the same value. It should give you the same results. We will solve questions afterwards, so you relax, okay?
So please, are we done and like deriving down with this one, the
No,
formula, the
no,
law?
we are not done. We are
Okay,
not
sir.
done.
Okay. Okay, sir. Thank you.
Okay. Now, you see, I earlier was saying that we can use this for separation of white light. Let me quickly sketch another triangle. Banjiwa, Eniwa, Frempoma. Hey, everybody is quiet too. So this is N1, N2. When we extend the incident light, it will go here. Good. When we extend the emergent light, it will go here. So this becomes the total deviation. This is the total deviation. Meaning that when you incident white light, what we know to be visible light, we know its visible light is made up of 7 constituent light or colors. So when you incident it at one side of the prism, because the light will go through double deviation at AB and at AC, and triangular prisms too has the ability to combine deviation 1, and deviation 2 to form a bigger deviation. When you incident white light, it will be dispersed into the various colors over this angle or range, starting from red, which is the least deviated, then followed by orange, followed by yellow, followed by green, blue, indigo, and finally violet. So the 7 component or colors of white light will be dispersed over this angle, which we are calling as the total deviation. This is how the triangular prism is used for the dispersion of light. So because it has the ability to combine deviations at both planes, it combines it to form a larger angle or deviation. And this is the range within which the colors of the visible light are dispersed. Class, are you okay? Red is the least deviated. Red is the least deviated. If red is the least deviated, then it means the refractive index of the color red is less. Violet is the most deviated. Violet is the most deviated, meaning that the refractive index of the color violet is high. From this class, we can therefore say that the refractive index of a material, the refractive index of a material is not constant. Refractive index of a material is not constant, but it depends on the color of light entering into the material. Class, are you there?
Yes, please.
The refractive index of a material depends on the color of light, okay, in the material. You see, the refractive index of glass, which is 1.5. This 1.5 value we talk of is using the visible light, using visible light. So if we use the visible light, which enables us to move around and see, then glass would bend this light 5 times as can be done by air. However, if we incident a particular color, maybe red light, maybe yellow or blue, the same glass will bend the light differently, because this time it isn't visible light, but it is of a different color. Class, I hope that's okay.
Yes, please.
All right. Is there any question? All right. If there is no question, then let's look at minimum deviation. I must finish this. The concept of minimum deviation. Joshua.
Say please, refractive index of. I could not complete that.
I said the refractive index of materials are not constant. But rather depends on the color of incident light. Okay. Refractive index
sir.
of materials are not constant, but rather it depends on the color of incident light. Because I'm recording, that's why I'm not sort of completing statement or writing statement in full and all that.
Okay, sir.
So minimum deviation of minimum deviation under the same concepts. Theory and practicals and the refraction of light in triangular prism has said that as we increase, as the angle of incidence, increases, the total deviation within the prism also decreases. What I'm saying here is that as we increase the angle of incidence, I, through theory and practicals in the lab, shows that as you increase I, you realize that the total deviation would also be decreasing. Meaning, when I is equal to 0, D total will be at its maximum value, will be maximum. Okay, and as we increase I, maybe I is increased to 30, then D would then be decreasing. If we increase I to 40, D total will be decreasing. Okay, so if as I increases, D total, this is in increasing order. This is decreasing. This is also, let me rather show it this way. This also decreases. So from maybe 0, 10, for I mean 20, 30. Let's assume this is from a highest value of maybe 50. Then it will decrease to maybe 40. This will 20, it will decrease to 30. When this is 30, this will be 20. When this is 40, this will be 10. When this is 50, this will be maybe 5. So as I increases, the total deviation would also be decreasing. But this order of decreasing total deviation would happen and then get to a certain value, and then from there would be increasing. So ideally for I, the trend is that we are increasing it. But for the total deviation, as I increases, it will be decreasing to a certain point. It will decrease to a certain point and then begin to increase. So 60, maybe this will be 10. 70, this will be 20. 80, this will be 30. So as I increases, the total deviation will be decreasing, but it will only decrease to a certain level and from there begin to increase. Class, are you okay?
Yes, please.
Now, yes, Gideon.
So please, the level at which the total deviation will reach before it starts increasing, will that point be negative?
No, it will not be negative. You see, we were increasing it. As for I, we are increasing it. But the total decrease, and got to 5 from, I'm just using value or guessing values. Gets to 5 and from 5 begins to increase again. Okay, begin to increase even though I is being increased. At that point, at that angle of incidence, which gives us that least or minimum value of total deviation, something important would happen. So at the minimum deviation, through theory and practicals, it is seen that at the minimum deviation, that is the point where the angle of incidence becomes equal to the angle of emergence. If you remember, when we started, I said that for refraction of light in triangular prism, the angle of incidence isn't always equal to the angle of emergence, but it happens at a particular condition. And this condition is what we are discussing. At the minimum deviation, that is where the angle of incidence would be equal to the angle of emergence. That is one. Two, at the minimum deviation, the first angle of refraction, R1, is also equal to the second angle of refraction, R2. So when you see point where I is equal to E, R1 is equal to R2, then it is at the minimum deviation. Class, are we okay? Hello, are we okay?
Yeah.
So at the minimum deviation, theoretically, the incident ray or the ray passes through the prism symmetrically. It looks as if at the minimum deviation, the ray divides the prism, okay, the prism into two. So we said that at the minimum deviation, one, ray passes through the prism symmetrically. Two, the angle of incidence is equal to the angle of emergence. And then finally, the first angle of refraction is equal to the second angle of refraction. So these are what happens at the minimum deviation. Very, very, very examinable point. State what happens at the minimum deviation when a ray of light passes through a triangular prism. One, the ray passes through the prism symmetrically. Two, the angle of incidence is equal to the angle of emergence. And the first angle of refraction is equal to the second angle of refraction. Please, is there any question? Okay, I want to quickly finish this. So if you have so let's look at what happens at the minimum deviation. At the minimum deviation, that's all.
So, please, what about the angle of deviation for both?
No, you see, the total deviation, which is now the minimum deviation at this condition, is it includes R1 and R2. Okay, I'm coming to even write an equation. You see, earlier we saw that D total is equal to I plus E minus A. When we get to this angle of incidence, which gives us the least deviation, and I use numbers. I said, assuming from our data, let the minimum deviation be 5. Okay, at this point, then the total deviation within the prism will be that minimum deviation of 5. dm, meaning we are replacing the minimum, the total by minimum, because we are at that point we are at the least deviation. So it's not total again, but the least deviation. That's why I'm changing T to M. If at the minimum deviation, angle of incidence is equal to angle of emergence, then I can say that dm will be equal to I plus another I minus A. I'm changing E to I because they are equal. I can also be equal to E. Okay, so dm will be equal to 2 times the angle of incidence minus A. So when we get to that, the minimum, that angle of incidence, which will give us the minimum deviation, this will be the expression for the minimum deviation. The minimum deviation will be equal to 2 times the angle of incidence minus the angle of the prism. Class, are we okay? Class, are we okay?
Yes, please.
So
We can, okay.
So you see that A is equal to R1 plus R2. And when
Yes.
at the minimum deviation, the first angle of refraction is also equal to the second angle of refraction. So can it be dm is
Exactly,
equal
you
to
are right. So A would also be equal to, you see, this time around, at the minimum deviation, R1 is equal to R2. So we wouldn't have R1 separately, we wouldn't have R2 separately. All that we'll have is a certain angle of refraction R. So we can also say that at the minimum deviation, A, which is R1 plus R2, will simply be equal to 2R. A will be equal to 2R. Ashima, are you okay?
yes, please.
Good. And we can use these conditions at the minimum deviation also to find the refractive index of the material used as a prism. From refractive index is sine of I over sine of R1. At the minimum deviation, let's make I the subject. Help me make I the subject from this equation. Oh, let's hurry up.
So
The
this it will
minimum
be the
deviation plus A over 2.
So I will be equal to the minimum deviation plus A divided by 2. So at the minimum deviation, this will be the expression for the angle of incidence. At the minimum deviation, we wouldn't have R1, R2. All that we'll have is a certain one angle of refraction. So this R1 will be equal to R. Then if A is equal to R1 plus R2, and they will all be equal to just R plus R, because R1 will be equal to R2, and R2 will be equal, so they will all be R. R therefore is equal to A over 2. Therefore, the refractive index of the material used as a prism at minimum deviation can be obtained by sine of I, which is now dm plus A all over 2, all divided by sine of A over 2. So at the minimum deviation, this will be the expression to determine the refractive index of the material used as a prism. So, but note that whether we are at the minimum deviation condition or not, the refractive index of the material used as a prism wouldn't change. It will be the same value. Class, are we okay? We have 8 minutes, and I want us to quickly solve a question. Let's use what we have learned to quickly solve the question.
Sir, please, it sounds like your voice is from afar.
Oh no, I'm not afar. I'm at your at your door. Okay, if in a prism, please put down the question. If in a prism, A is equal to 60 degree, A is equal to 60 degree, and the refractive index is 1.52, and the refractive index is 1.52, calculate the minimum deviation, calculate the minimum deviation of a ray of light, calculate the minimum deviation of a ray of light that passes through it symmetrically. Calculate the minimum deviation of a ray of light that passes through it symmetrically. If in a prism A is equal to 60 degrees and the refractive index is equal to 1.52, calculate the minimum deviation of a ray of light that passes through it symmetrically. So a quick try, okay? I wish we have enough time to solve questions. Solving questions will help bring clarity. So here you have to calculate the minimum deviation. Are we through? Hello, are we through?
So please, can the minimum deviation be negative?
No. It must be positive. Okay, so now please pay
So please, I'm
attention.
done.
You hold
So please, I'm
on.
done.
Hold on. You see, we derive two different relations. We saw that if we are not at that angle of incidence, which will give us a minimum deviation, the total deviation in the prism is equal to I plus E minus E. And the refractive index is sine I over sine R1 or sine E over sine R2. If I'm told that the ray passes through the prism symmetrically, or if I'm given a value, any information, look at this question. We are told that calculate the minimum deviation. Once there is that talk about minimum deviation, then you must use equations concerning anything minimum deviation. So in this case, at minimum deviation, the refractive index will certainly be equal to sine of dm plus a all over 2 over sine of a over 2. I can also use sine I on sine r, but I know that I is equal to, I in this case will be equal to dm plus a over 2, and r is equal to a over 2. And then come and substitute this into it. So the question provides the refractive index 1.5. So if I want to use this sine I over sine r, I have 1.52 is equal to sine I over sine of, I need r, but do I have the refraction angle? Yes, that is 60. So 60 over 2 means that r is 30. So I have sine I being equal to 1.52 times sine 30 degree. Class, are you following? Are we following?
Yes.
Yes, sir.
Sine 30 is half, so I have 1.52 times 0.5. Help me find I. So multiply this by this and find the sine inverse. What will be the value of sine? I.
So please, 49.464.
49.46.
0.46.
Okay, please confirm it for me, okay? So if I is this, then I can easily find my minimum deviation, because I know that minimum deviation is equal to 2i minus a. So if I is 49.6, I have 2 times 49.46 minus the angle of the prism, which is 60. Multiply 2 by 49.6 and subtract 60 from it. And you must have 38.92. Check if that's correct.
Yes.
Sir, please, 0.93 instead.
Okay, so 38.93 degree is the minimum deviation. So, but the truth is you can also use this. You can also use substitute 1.52 for this, substitute what you have for A, and then it's just must make dm the subject. That's all. So this is an application of shared problems. I'll give you an example to try your hands over the weekend, okay? But please spend time to review the theory, how we derive the equations at minimum deviation and without minimum deviation. Then when I give you examples, you can easily solve it, okay? So please spend time to go through it again. If you don't understand anything, please do not hesitate to send it to me and I'll respond to you via WhatsApp, okay? As usual, I'll upload the video. It is 1 minute past our time. Then this is where we draw the curtains on today's meeting. Please, those of you who have joined us afresh, when you go to the page, subscribe, okay, and then share to your colleagues and all that, just to grow the channel for me. Until next week, may the good Lord be with you. Take care of yourselves. And please, those of you who are fond of not submitting assignment to, please do so for me. It is for the good of the goodness of you and Omega as well. Bye bye, and we'll meet once again next week.